Good day, my name is Javad Karim and I am part of Group 19, a former engineering team, and we represent a company known as JASA, a private research and development organization. Our task at hand here today is to create a device that is able to efficiently desolder an electrical circuit board and retain the solder, electrical components, and the printed circuit board in order for it to be recycled. Each of us here today possess unique engineering attributes that when combined shall lead to the successful completion of this task. Here with me today is Arisha Ali, Anthony Jamrati, and Shana J. I myself bring to the group the skill of critical and logical thinking as well as the SolidWorks program. I am very well versed in it.
Good day, my name is Arisha Ali, and the engineering attributes that I contribute to this group include researching, critical thinking, and organizational skills.
Hi, good day, my name is Anthony Jamrati, and I bring to the group proper communication among members and to the company, and I also offer my skills in SolidWorks.
Good day, my name is Shana J. The engineering attributes which I possess include attention to detail, research, and I am also well versed in mathematical hand calculations. These will come in very useful in the design process. Thank you, and please enjoy our presentation.
A printed circuit board is an electronic circuit consisting of thin strips of a conducting material, example copper, which has been etched from a layer fixed to a flat insulating layer to which integrated circuits and components are attached. Originally in the 1850s, metal rods and strips were connected to electrical components mounted on wooden bases. As time went on and technology progressed, smaller, more compact designs were needed due to increased operation speeds, leading to the formation of printed circuit boards. This concept was brought about in 1925 by Charles Ducas, who invented a way of creating an electrical path directly on an insulated surface by printing through a stencil with electronically conductive ink. However, this was not executed until 1943 by Dr. Paul Eltzler in Austria. Hot air soldering is a way to solder a surface-mounted device onto printed circuit boards by using hot air needles to dispense solder. In 1980s, surface-mounted components became the preferred method of attachment of components to PCBs, leading to what is used in devices today. PCBs are made of many toxic materials that can be harmful to the environment and to humans. With the increase in e-waste, an interest has grown into recycling of these printed circuit boards. Due to complex composition of PCBs, recycling is not easy.
Printed circuit boards are found in many electronic devices today. All electronic components are soldered into place on the board. However, this results in many printed circuit boards being replaced due to one of the electrical components malfunctioning or failing. These boards are often discarded, resulting in a wastage of material, including solder and electrical components piling up in landfills. An interest has been shown in the recycling of these materials, which some companies are looking to exploit in order to make a profit. This project intends to design a device that will allow for the components and solder to be separated from the circuit board and collected. This device can be sold either wholesale or retail to make a profit.
The aim of this project is to design a machine that allows for solder and electric components to be separated and collected from printed circuit boards.
Objectives. This project intends to satisfy the aim by meeting the following: using a literature and content review, which involves the analysis of previously published material on the topic; using the design process, which involves obtaining client and user requirements from which key attributes are generated. Metrics are then obtained for these key attributes. A functional analysis is used to determine the primary and secondary functions of the device. A morphological chart is used to determine the means by which these functions can be carried out. A combination of these means is then used to generate concepts from which a final design is selected. Calculations and simulations will then be run on this final design and a model created. Literature review. The literature review was done by analyzing various articles that were published on the topic of printed circuit boards and the recycling of these circuit boards. From the research, it was found that technology is constantly changing to accommodate the needs and demands of society. Thus, devices today are required to be smaller and operate faster than in the past. This led to the invention of printed circuit boards, which replaced previous methods of signal and power transmission. What are printed circuit boards? Printed circuit boards are the main component of most electronic devices today. They consist of roughly 40% metals, 30% organics, and 30% ceramics, but this composition can vary based on the application. There are three types of circuit boards: single-sided circuit boards, double-sided circuit boards, and finally multi-layered circuit boards. Single-sided circuit boards consists of one conductor layer, where the components are all located on one side and the circuit is on the other side of the board. Double-sided circuit boards are able to hold more components than single-sided circuit boards. These are the most popular type of printed circuit boards. They are also known as the doorway to higher technology applications. Finally, multi-layered circuit boards made up of layers of substrates separated by insulation. The need for recycled printed circuit boards. Due to the rapid innovation of technology, devices are being discarded at a quicker rate. Thus, many printed circuit boards are being discarded. These printed circuit boards contain many toxic substances such as lead and chromium, and many precious metals such as gold, which have the potential for bioaccumulation and can negatively impact the environment and the human body. Additionally, many of these printed circuit boards have components which are still fully functional and can still be used in other devices and thus can be recycled. However, before recycling can be done, the components must be separated from the printed circuit boards. This can be done either chemically or using heat. The chemical process involves selectively dissolving solder using a leachant. The leachant must be selected in order to not affect the electrical components which contain metals such as copper. The heating method involves the use of a source of heat, usually a soldering iron, and a means of removing the molten solder. For example, a soldering pump. An example of a soldering iron and a soldering pump are shown in the following slides. Patent review. This section involves the analysis of previously designed devices. The first patent review involves a device invented by Ralph Eversole. It consists of an electrically conducting plate connected to a heating gun. It has a tip specifically designed with projections that correspond to locations of contacts on the board, allowing it to desolder multiple contacts simultaneously without damaging its PCB. Advantages of this design include: it can desolder multiple contacts simultaneously. It can be used to remove components that have a multitude of pins that are connected as a unit. Also, it does not damage the circuit board due to the projections maintaining the distance between the plate and the board itself. Disadvantages include that it can only be used for a specific arrangement of components. The device does not collect the solder. It can also become tedious to use if it is applied to a large circuit board. This device consists of a four-legged frame attached to a weakened plate with an electrically conductive cover and a suction device. It uses a marking projector to ensure components are oriented accurately, and it removes solder by the use of solder leaf and collects components without causing damages. This device has many advantages as it can desolder multiple contacts simultaneously. It does not damage the circuit board due to the use of solder leaves. It can be used for multiple size boards. It can be used for multiple arrangement of components. It recollects the solder, and the frame can be used to solder new components. However, it comes with some disadvantages, as the components must be manually removed or inserted. Seals must be regularly checked and replaced on the suction device, and it is expensive. The device that is to be designed must meet specific criteria that was expressed by the client, such as easy and inexpensive to manufacture, where the manufacturing cost should be low to maximize profits obtained when the device is sold by the company. Safe operation, where the device should be safe for both skilled and unskilled workers. Ease of operation, where the device can be used without extensive training. Portability, where the device should be lightweighted and be able to separate into parts. Preservation of PCB, where the device should not damage the PCB or the components. Energy efficient and economic output, where the device should use relatively low quantities of energy to produce relatively large product outputs.
For the design specifications, the machine should be of a material such that it will be able to withstand at a high temperature of constant heating without deformation or damage. The machine should be of a size such that it would be suitable for small-scale industrial applications and not be oversized such that it would be difficult for workers to use. The machine should be designed in such a way that the operator could remove the components easily without harming himself for purposes of maintenance and also to use the machine. Whether operational or not, the machine should be safe to use and not a risk to anyone in the vicinity of the machine. The machine should be specific to one application, that is a 100 by 80 mm single-sided printed circuit board with surface-mounted components. In this section, we deal with the design constraints. The design constraints are those factors which limit the scope of the design. Such constraints are the machine's components can't be large or heavy, such that it would be difficult for the operator to do work or do maintenance on. The machine's process can be sped up so to decrease the time taken for it, as it would result in damage of the PCB. The machine is a small-scale application and can only process a small amount of PCBs at a time. The machine is not fully automated and thus requires some manual labor from an operator. And lastly, the machine cannot exceed the melting point of the PCB.
From the client and user requirements, the key attributes for the device were identified. Metrics were developed using a 1 to 3 scale, 1 being the worst and 3 being the best. For example, inexpensive to manufacture, 1. Production cost is high, 2. Production cost is affordable but can be cheaper, 3. Production cost is low.
A pairwise comparison was done using a few chart. The key attributes were listed and compared. From this, the relative weightings were determined, and from the chart it can be seen that the most important key attribute is that the device is inexpensive to manufacture. The least important key attributes are that the device should be energy efficient and easy to operate.
The first part of the functional analysis involves the use of a black box. The yellow black boxes indicate the inputs to the device, including the energy, the material, which is the printed circuit board, and the information, which is the power required to melt the solder. It goes into the device, which performs the primary function of separating electrical components from printed circuit boards. The outputs are given in the orange boxes, which include the separated electrical components and printed circuit boards, the melted solder, and the output of heat energy losses, such as heat, sound, and vibration. This is a detailed black box in which the primary function was broken down into separate secondary functions, which are highlighted in the orange boxes. These secondary functions include heating the solder, removing and collecting solder from PCB, collecting the electrical components, and retrieving the PCB. The function's main tree was then generated, which involved the primary function, highlighted in the red box, being broken down into the secondary functions, which are in the orange boxes, followed by the means to accomplish each of these secondary functions in the yellow hexagons. For example, the secondary function of heating solder can be done by using hot air, a heating plate, or a heat gun.
A morphological chart identifies various options that can be used to accomplish specific functions in the device. For example, generate heat, hot air, current coils, heat gun, solar panel, and insulators.
In the three figures shown here are the three conceptual designs that were put forward by the engineering team. Concept A incorporates a heating lamp attached to a table and a mesh plate for the PCB to be placed on. Once the PCB is heated, the solder runs through the mesh into a collecting tray. The operator then turns off the heat lamp and removes the components from the PCB. Concept B utilizes the general shape of a concrete mixer, which consists of a hollow shaft through which a hot air and a vacuum tube passes. The PCBs are placed on slotted discs through the shaft. The hot air melts the solder and the vacuum tube removes it. The components are dislodged by vibration from the gas engine, which also produces the hot air. The components fall into a mesh which an operator then removes afterwards. Concept C involves a motor control belt and a heating box. The PCB is placed on the groove of the belt and is moved to the heating box where it is heated so that the solder is melted. Once melted, the solder is vacuumed and the components fall into a collecting tray and removed.
The design selection involves two parts. The first part involves the rating of the concepts. The three conceptual designs were rated with the key attributes using the metrics that were generated earlier. The designs were assigned a value based on how well they satisfied each of the key attributes. The second part of the design selection involves the selection matrix, which uses the relative weighting of the key attributes along with the raw scores obtained from the rating of the concepts to generate a weighted score for each of the three concepts. The design concept with the highest weighted score was found to be concept B, which indicated that it satisfied the key attributes and thus the user requirements the best out of the three concepts, thus eliminating both concepts A and C.
From the selection matrix, it was determined that this concept is best suited to fulfilling the client's requirements. This concept will be further developed and refined in order to efficiently carry out the required task. Based on the data gathered, this design is the best suited solution to meet our requirements. As seen in the figures, the device is made up of three main components, which are the shaft and plate, the drum, and the motor. This design has the capability of desoldering multiple boards at a time, and also requires minimal manual labor. This concludes our presentation, and references for the sources of information can be found in the following slides. Thank you.